Good morning to all my students. Myself is Dr. Santosh Choudhury, reader in chemistry. Last class we will discuss, that is in organic chemistry class number 3, some physical properties and the reactivity order of alkyl halides. The reactivity order of alkyl halides depends on carbon halogen bond strength. As the bond strength increases, the reactivity order of alkyl halides decreases. That means alkyl iodides are more reactive as compared to alkyl bromide, as compared to alkyl iodide. The reactivity orders of alkyl halide having particular halogen, that is your tertiary alkyl halide is more reactive than the secondary alkyl halide, than the primary alkyl halide. Okay students, you know the alkyl halide always shows the nucleophilic substitution reaction. The nucleophilic substitution reaction means the halogen atom of alkyl halide gets substituted by a stronger nucleophile, means that nucleophile is known as entering group, whereas the halogen atom from alkyl halide is known as the leaving group. So today we will start what is SN1 reaction, SN2 reaction. Before coming to SN1 reaction or SN2 reaction, that means SN1 means nucleophilic substitution unimolecular, and SN2 means nucleophilic substitution bimolecular. So, what do you mean by this unimolecular or bimolecular? That means the molecular, you have to know what is molecularity. So, according to the law of mass action, the rate of the chemical reaction is directly proportional to the molar concentration of the reactant and each rise to the power of the stoichiometric coefficient in the balanced chemical equation. That means, suppose if you take m moles of A react with n moles of B, you will give the product. Then rate is equal to some constant, that is called specific rate constant or simply rate constant, into molar concentration A to the power m, B to the power n. So molecularity means the number of reactant molecules required to initiate the reaction. So molecular means the number of reacting species or molecules required to initiate the reaction. Once the reaction initiated, it will progress. So when I say this is a unimolecular reaction, means the reaction initiated by a single reacting species. That is, unimolecular means the molecularity is 1. So What you mean molecularity is 1? During the reaction, suppose alkyl halide when treated with a, suppose this is your alkyl halide, when react with a nucleophile, it gives the, no doubt, R and Nu, this is your product. The reaction initiate, you see in this reaction, it is one of the reactant, this is another reactant, that is called attacking reagent. So, the reaction initiate begin with either alkyl halide or nucleophile. That's why you can say the molecularity is 1. Means when you study the mechanism, the reaction initiated by the only one reacting species, that is your alkyl halide or nucleophile. You let us see in the mechanism. Similarly, what do you mean by bimolecular reaction? Bi means 2. The reaction which initiated by 2 reacting species, that means the reaction initiated by alkyl halide as well as nucleophile, means both are required at a time. Both are involved in the reaction at a time. That's called your bimolecular reaction. Means you conclude that the unimolecular reaction means the reaction initiated by unimolecular means reaction initiated by only alkyl halide. In initial step, the reaction starting with alkyl halide. In next step, the nucleophile may be required. In bimolecular reaction means the reaction initiated by alkyl halide as well as nucleophile. Okay, so bimolecular means the reaction initiated by the alkyl halide as well as nucleophile, but unimolecular means the reaction initiated by only alkyl halide molecules. I think you know what is molecularity means the number of reacting species required to initiate the reaction. In case of unimolecular reaction, the molecularity is 1. Means the reaction is initiated by only one reacting species. When you say the bimolecular reaction, means the molecularity is 2. The reaction initiate or start with the alkyl halide as well as the nucleophile. Next come to what is the order of the reaction. For example, if you take a reaction M moles of A, react N moles of B, give the product, then you know according to law mass section, rate is equal to K into molar concentration A to the power M and B to the power M. What is A? A is one of the reactant. What is B? Another reactant. What is M? M is a coefficient. The coefficient of A is M and coefficient of B is N. And rate is equal to K into A to the molar concentration A to the power M, because the coefficient is M, and molar concentration B to the power N, because the coefficient is N. So what is the order? Order became M plus N. That's called order. Okay. Suppose the rate is equal to K into molar concentration of Rx. Means it concentration power is 1, so this is called order is equal to 1. In bimolecular reaction, that is rate, this is for unimolecular reaction. In case of bimolecular reaction, rate is equal to alkyl halide into the nucleophile. In this case, order is equal to 2. That means the rate depends upon the concentration of alkyl halide as well as the nucleophile. But in this case, the rate depends upon only alkyl halide. This is for bimolecular reaction. Okay, students, we can know what is molecularity and what is order. Order means the sum of power of molar concentration tau in the rate law equation is known as order. That means the sum of power of molar concentration tau in the rate law equation is known as order of the reaction. Are you clear? Now you know what is molecularity, what is order. Next you come to you discuss some about the optical isomerism. In optical isomerism, you know what is D form, what is L form, and what is the enantiomer, what is racemic form, all these things. It will little bit required in this chapter. So, you know, isomerism means same molecular formula but different structures. And the different structures are known as isomers. You know, there are isomers are different form of compound, different form of the compound is known as isomer. Means same molecular formula but different structures are known as isomer. A molecular formula minimum one more structure is known as isomer. Okay. Next come to what is an optical isomer. What is an optical isomer? Optical isomerism means optical is one related to the light. The light means one form of energy which consists of a electromagnetic wave as well as electrical wave. That means the light consists of two fields, electrical field as well as magnetic field. The light is a source of the light. It can propagate only direction, and this light is called unpolarized light. So, when the light is radiated from a body, it can propagate all around it, and that light is known as unpolarized light. When unpolarized light passing through a slit, this is called your Slit means a small narrow path. Slit means small narrow path through which the light can propagate only one direction, and this is known as plane polarized light. Okay? That is the light which can propagate only one direction along the x-axis, or you can say y-axis or the z-axis. Then you can say plane polarized light. That means for optical isomerism, we must require a plane polarized light. So when the plane polarized light passes through this is your aqueous solution of organic compound. Aqueous means the organic compound dissolved in water. That's called aqueous solution. When the aqueous solution light passes through, you see some light get reflected back. Some amount of light is absorbed by the organic compound and some light is transmitted. This is your transmitted light. Means the plane polarized light after passing through the organic compound. Suppose this is your x direction. This is maybe also a x direction. Means there is no change in direction of the transmitted light after passing through the what? Organic compound. And that organic compound which cannot rotate the plane polarized light, then that organic compound is said to be optical inactive. Optical inactive compound. Optical inactive compound means the aqueous solution organic compound which cannot rotate the plane polarized light when it passes through it. If the transmitted light is rotated, for example, if you take you see the polarized light, this is the direction actually, but it is not, it is rotated in this direction or in this direction, and this is say anti-clockwise and this is your clockwise. Then the organic compound said to be optical active. That means the aqueous solution organic compound which can rotate the plane polarized light either clockwise direction or in anti-clockwise direction, then it is said to be optical active organic compound. So, depending on the rotation of plane polarized light by the aqueous solution organic compound, the organic compound can be classified as optical active and optically inactive. So, that is optical active organic compound, that means rotate the plane polarized light. either clockwise or anti-clockwise direction. Then what is optical inactive compound? That is, optical inactive compound means which cannot rotate the plane polarized light. They are said to be optical inactive compound. Okay, the optical active compound can exhibit optical isomerism. That means any organic compound which can rotate the plane polarized light either clockwise direction or anti-clockwise direction, that compound can exhibit the optical isomerism. Not all the organic compound. Only the optical active compound can exhibit the optical isomerism. Okay? Now, optical isomerism means minimum two form, two different structure, minimum. And out of the one form, if it rotate the PPL, that is our plane polarized light, clockwise direction, means in this direction, this is your transmitted light path. And another form, two form means another form, rotate the PPL anti-clockwise direction, means in this direction. This is the transmitted. The isomer means the form which rotate the plane polar line in clockwise direction. Then you can say this is D form. What form? D form. D means dextrorotatory. And the form which rotate the plane polar line in anticlockwise direction, that is called L form. Okay, students? So, optical isomers means structures or form, is called, one is called D form and is called L form. So what is D form, L form? D form means the optical isomer are optical compound which can rotate the plane polarized in clockwise direction. Then we can say D form. When we rotate in anti-clockwise direction, then you can say it is L form. So any optical active compound, minimum a D form and a L form is there. Again, the D form and L form these two forms are related with each other. What they relate with each other? These two forms mirror image to each other. If D form is object, then L form will its mirror image. If L form is object, then D form is mirror image of L form. That's why these two forms are known as enantiomer. Known as what? Enantiomer. Enantiomer means these are the two forms which are image object to each other and related to each other, then they are said to be enantiomer. That means enantiomer is the pair of optical isomers which are mirror image to each other of a optical active compound. That's called enantiomer, and enantiomer means one is D form, one is called L form. Let us see, in the organic compound, carbon has 4 covalency. That means it has 4 covalent bonds. If the carbon atom undergoes sp3 hybridization, then it has tetrahedral structure. This is your tetrahedral structure, and this is one bond, this is another bond, this is another bond, and this is a bond perpendicular to this bond. Tetrahedral structure. And suppose the carbon atom bonded with 4 different atom or group. For example, this is A, this is B, this is D, this is E. You see, C is your carbon atom. This carbon atom is bonded with 4 different atoms. That is your one atom is A. It means hydrogen, chlorine, bromine, so many. A, B is another atom or group, C is another, D is another atom or group, and E is another atom or group. This is one of the structure of a compound having formula C, A, B, D, E. That means carbon bonded with 4 different atom or group. Suppose this is one of the structure of this one. What will be its image? Suppose I can put a mirror here. What is the image? You see, in your mirror there is a side change. So there must be change. This is your which side? Is in this structure. This is the right hand side. In your image, this is became which side? This is E, and this is A, this is D, and this is B. What do you mark? You mark the side chain with parshva parivartan hela. The E and A are in this structure in right hand side, whereas in this structure it is in what side? Left hand side. So if it is called D form, then it is your L form. And both this form is known as enantiomer. Why is it called enantiomer? Enantiomer means the pair of optical isomers having same physical properties, same chemical properties, but different in direction of rotation of plane polarized light. Means D form can rotate in clockwise direction, whereas L form rotate in the which direction? Left, anti-clockwise direction. Then those phase is known as enantiomer. Okay, students, I will give an example. For example, I will do, for example, this is CS3, CH, OH, C2H5. What is the name of the compound? 1, 2, 3, 4. That is butane 2OL. And the carbon atom is different, bonded with different atom or group, 4 different atom or group. That carbon atom is known as asymmetric carbon atom. What do you call it is? Asymmetric carbon atom. Means the carbon atom is bonded with 4 different atom or group. You see, this carbon is bonded with hydrogen, this carbon bonded with methyl group, this bonded with OH group, this bonded with C2H5 group, ethyl group. So this carbon is known as asymmetric carbon or achiral carbon. What carbon? Achiral carbon or asymmetric carbon atom. And it has a tetrahedral structure because sp3 hybridization. So when you say this tetrahedral structure, that is C2H5. Suppose this is your OH group, this is your CH3 group, this is your H. If it is the D form, what will be its L form? The L form is, that is C, this is C2H5, this is OH, this is H, and this is what? CS3, this is called L form. If it is rotate the plane polarized clockwise direction, and it will rotate in anti-clockwise direction. So this is called D form and L form. And for the condition of optical isomerism, the molecule should have at least one asymmetric carbon atom. Asymmetric carbon atom thiyaku. You see, this is not asymmetric carbon atom because this carbon bonded with 3 other hydrogen. Same 3 hydrogens. This is also not asymmetric. So the D form and L form, that means any organic compound which can exhibit the optical isomerism, it must have a 2 form, it must have at least one asymmetric carbon atom, means the carbon atom bonded with 4 different atom or group. Then only it can exhibit the optical isomerism. And one is D form and it's called L form. And we will be studying in higher class all about the D form, L form, a very important class, optical isomerism. Okay students, are you clear what is D form and L form? Suppose a compound containing both D form. The aqueous solution of organic compound have the D form plus L form. Both are can exist together. Will it rotate the plane polar light? The aqueous solution which contain both the D form and L form, will it rotate the plane polar light? it cannot rotate the plane polar halide, although possesses the D form and L form, because the rotation due to the D form, that means in clockwise direction, and get compensated by the rotation due to the L form, means anticlockwise direction, and the resultant is 0. Means the mixture having D form and L form, it cannot rotate the plane polarized light, because the rotation due to the D form is get compensated externally with the L form. And this mixture is known as racemic mixture. Racemic means contain both the D form and L form, or you can say this is called DL form. If you are individual, suppose you only take D form or only take L form, they can rotate the plane polarized light. When equal amount of D form and L form are mixed together, the resultant solution cannot rotate the plane polarized light, because the rotation due to the D form get compensated with the rotation due to the L form. Then that mixture is known as DL form or racemic mixture. Okay, student, this is all about something about the optical isomerism. Let us come to the topic. The topic is what is SN1 reaction and what is SN2 reaction. And SN1 reaction means nucleophilic substitution unimolecular, means the molecularity is 1 order also. Molecular 1 means the reaction begin with only one reacting species, that is begin with only alkyl halide, means there is no role of the presence of nucleophile during the reaction. And this type of substitution reaction shown by, observed by this SN1 reaction observed by tertiary alkyl halide, means the halogen atom bonded to a tertiary carbon atom. Allylic halide means the carbon atom bonded to a double bonded carbon atom. The halogen atom bonded to a sp3 which bonded to sp2, or it can observe by benzylic halide, means C6H5 CH2X. The halogen atom bonded to sp3 hybridized carbon atom which bonded to a benzene ring. So when these alkyl halides, the tertiary alkyl halide or allylic halide or benzylic halide undergoes any substitution reaction, means nucleophilic substitution reaction, it must undergo the SN1 reaction. So we can guess which type of alkyl halide undergoes SN1 reaction. Means it may be a torsade alkyl halide, it may be a allylic halide, it may be a what? Benzylic halide. Okay? So suppose you take a torsade alkyl halide. And this torsade alkyl halide, that means the halogen atom bonded to a torsade carbon atom, when treated with a nucleophilic reagent, means the halogen atom gets substituted by the what? Substituted by this nucleophile. You know, last class I have discussed what is nucleophile and what are these and some examples. It will undergoes a substitution product. That's a nucleophilic substitution product. You see what is the reagent here? Reagent is your tertiary alkyl halide. This is your nucleophile. There are two reagents. One is tertiary alkyl halide, another is your nucleophile. Now, when you say rate, that is, you put a rate constant K and molar concentration of tertiary alkyl halide only. That means when the concentration of tertiary alkyl halide increase by 2 times, the rate also increase 2 times. That means when the concentration double, rate is also double. When the concentration is to half, the rate becomes half. That's why the rate depends upon only the molar concentration of the alkyl halide. When the concentration of the nucleophile increase 2 times, what will happen rate? There is no change in rate of the chemical reaction. When the concentration decreases, there is no change in rate. When the concentration of nucleophile increases, there is no change in rate. Because the rate it depends upon only the concentration of the alkyl halide. So this is called what equation? Rate equation. In this rate equation, the molecularity is 1, order also 1. Means when you say order is 1, the rate depends only concentration of tertiary alkyl halide. Means when the concentration of tertiary alkyl halide increases, rate increases. When the concentration of alkyl decreases, rate also decreases. That's the order is 1. But the molecularity is 1. When you say the molecularity is 1, the reaction initiated by only the tertiary alkyl halide and there is no role of any nucleophile. That's why the order is 1, molecularity is 1. Okay, students? Now come to how the reaction is taking place. Means what are the mechanism? Mechanism means the pathway of the reaction. What is this pathway of the reaction? Pathway means, reaction means breaking up the bonds. First, then new bond is formed. So, mechanism means which bond will break first and what intermediate will form and how this intermediate further react another reactive species, it give to the product. That's called mechanism. In certain case, the mechanism may consist of more than one step. In some cases, it consists of one step also. So, let us study the mechanism of SN1 reaction. The mechanism of SN reaction, it consists of two steps. That is, step 1, formation of carbonium ion. So what do you mean this carbonium ion? Carbonium ion means carbon atom having positive charge. And that is called what atom? What ion? Carbonium ion. First step, the formation of carbonium ion. Then how the carbonium ion is formed? You take this is your tertiary alkyl halide in presence of a polar solvent, or what you call ionization solvent. That means this solvent can break this molecule, that this is fractional negative, this is fractional positive. When this will be break, you see the molecule, the reaction start only alkyl halide, not required any nucleophile. This break heterolytically as a result to form a carbonium ion and this halide ion. And this is called carbonium ion as a reaction intermediate, and this carbonium ion undergoes sp2 hybridization and trigonal planar structure. That means in SN1 reaction, the tertiary alkyl halide molecule, the carbon halogen bond break heterolytically, unsymmetrically to form a carbonium ion in which the carbon atom carrying positive charge and the halide ion. And this carbonium ion undergoes the state of sp2 hybridization. Due to the sp2 hybridization, it has a trigonal planar structure. Next question, this one is called slow step. That means which can control the rate of chemical reaction, slow step. And the slow step is also known as rate determining step. Okay, students? So, the first step of the SN1 reaction, the formation of carbonium ion. Carbonium ion means the carbon atom carrying the positive charge, and this carbonium ion can be formed from tertiary alkyl halide or allylic halide or by benzylic halide by cleaving the carbon halogen bond heterolytically. Okay, students, next come to step 2, attack of nucleophile. After the formation of the carbonium ion, which is a trigonal planar structure, and the nucleophile which is stronger than the halide ion, it will attack to this positive carbon atom either above the plane. This attack is called above the plane, or it may be attack below the plane. And this is your above the plane, and this is your below the plane. This step is very first step because negative positive attract to each other. So when above the plane or below the plane will give same structure to different structure. When it will attack nuclear attack above the plane, it will remain above this one. When it attack this will rise below this one. So in this case, we will get two type of structure, that is your C Nu or Nu, and another structure Nu. If it is D form, then you can say it is your L form, and the mixture you will get a racemic mixture. And out of this one of the called retention structure, and it's called inversion structure. What is a retention structure? In retention structure means the nucleophile. This nucleophile is substituted the same side of the halogen atom. That means if it is torsioalkyl halide, nucleophilic reagent, it will come to this one, then you can say this is retention. When it is opposite side, then this structure called inversion. Are you clear? That is, the nucleophile is substituted for the halogen atom of alkyl halide, the same side, that is called retention. When they are opposite side, they are called inversion structure. Okay? This is all about your mechanism of SN1 reaction. The SN1 reaction consists of two steps. Mechanism of SN1 reaction consists of two steps. First step is formation of carbonium ion. Second step is formation of or attack of the nucleophile. Okay, students, are you clear what is SN1 reaction? Now come to what is meant by SN2 reaction. SN2 reaction means nucleophilic substitution bimolecular reaction. That means the molecularity equal to 2, order also 2. When you say molecularity is 2, means to initiate the reaction you will require the nucleophilic reagent as well as the alkyl halide. And this type of reaction generally shown by primary alkyl halide, somewhat secondary alkyl halide. That means the secondary alkyl halide sometimes it shows SN1 mechanism, sometimes it shows SN2 reaction. It depends upon the other factors. Okay, so when in primary alkyl halide that is RCH2X, this is your primary alkyl halide treated with nucleophilic reagent, it gives the product RCH2Nu plus X minus. This is your substituted product. In this case, rate is equal to K into molar concentration of RCH2X into Nu minus. So the molecularity is 2, order also 2. Means when the concentration of the alkyl halide increase by 2 times, rate is increased 2 times by keeping the concentration of nucleophile constant. If you increase the concentration of the nucleophile 2 times by keeping the concentration of alkyl halide constant, the rate is also increased 2 times. That means the rate depends upon the concentration of alkyl halide as well as the nucleophile. Suppose when you increase the concentration of the nucleophile 2 times and nucleophilic on 2 times, the rate became 4 times. Rate became 4 times. That's why the order is 2. Okay, so what is the mechanism of this one? The mechanism of this one is consist of one step, that is formation of transition state. What is transition state? That is one of the type of intermediate. Suppose you take a primary alkyl halide RCH and X. This is your primary alkyl halide. Due to inductive effect, this possesses fractional negative charge, this possesses fractional positive charge, and this is your nucleophilic reagent. You see, you require both at a time. What will happen? Thus, nucleophilic reagent will attack to this carbon atom opposite side of that of the halogen atom. Because this is negative, they repel each other. So it preferably attack to this carbon atom opposite side of the halogen atom. And when it will attack, the nucleophile is partly bonded with carbon, and the outgoing halogen atom also partly bonded. And from a transition state the transition state, that this is your nucleophile just entering into the carbon atom, and this is your outgoing halogen atom, and this is your R, this is your H, this is your H, and this is called your first state. This is called a transition state. You see, this transition state, the carbon atom possesses 1, 2, 3, 4, 5 valency. But carbon has 4 valency. When it is a 5 valency, it became unstable. So, the formation of the transition state by the attack of the nucleophile from the opposite side of the halogen atom to the carbon atom is a slow step. So, formation of a transition compound is a slow step. After the formation of the transition state, which is quite unstable because the carbon atom is pentavalent. Next, it immediately this became a first step, and this will be totally outgoing. It became a new R H H plus X minus. This is your substituted product. Okay, students, and this is the mechanism of SN2 reaction. And what you will get here, you see the halogen atom here is right hand side, but the nucleophile here is in product in the what side? Left hand side. So you get a what product? You get a inversion product only. That is, the deformed alkyl halide undergoes SN2 reaction. It always gives L form product. Okay, students, this is all about your SN2 mechanism, and SN2 mechanism consists of only one step, the formation of transition state. The transition state can be formed by the attack of the nucleophile from the opposite side of the halogen atom. I think you may some idea about the SN1 reaction and SN2 reaction. SN1 reaction means nucleophilic substitution unimolecular, means the molecularity is 1, and SN2 reaction means nucleophilic substitution bimolecular, the molecularity is 2. Okay, can you differentiate between the SN1 reaction and SN2 reaction? What is the difference? The SN1 reaction always shows by tertiary alkyl halide, benzylic halide, or allylic halide. Whereas the SN2 reaction always shown by primary alkyl halide. Why? Because the tertiary alkyl halide or benzylic halide or the allylic halide, which undergoes the ionization to form a stable carbocation, whereas the primary alkyl halide, which undergoes ionization, means cleavage of the carbon halogen bond, does not give a stable carbocation. That's why any primary alkyl halide never shows SN1 reaction, it always shows SN2 reaction. Second difference, in SN1 reaction, the molecularity is 1, order is 1, but in SN2 reaction, the molecularity is 2, order also 2. That means in SN1 reaction, the reaction initiated by only alkyl halides. But in SN2 reaction, the reaction initiated by the alkyl halide as well as the nucleophile. In SN1 reaction, the mechanism consists of two steps, that is formation of carbonium ion. The second step is attack of the nucleophile to the carbonium ion, whereas SN2 reaction mechanism consists of only one step, the formation of transition state. Okay, and in optical isomerism, the SN1 reaction always gives a racemic mixture, that is mixture of D form and L form. Means if you starting with a active alkyl halide, the product is racemic. On the other hand, in SN2 reaction always gives a inversion product. Means if the alkyl halide is a D form, the product is a L form. Because in SN1 reaction, the nucleophile will attack to the intermediate carbonium ion. Because it's trigonal planar, above the plane it gives D form. When it attacks to the below the plane, it gives L form. But in case of SN2 reaction, the nucleophile attack to the carbon atom in opposite side of the halogen atom. That's why in SN2 reaction always gives a inversion product, whereas in SN1 reaction it gives the racemic product. Okay, students, and there is any others or that is not in nuclear course. There is a many more difference between SN1 and SN2. It's just like for SN1 reaction, preferably polar solvent, high temperature, weaker nucleophile. Whereas in SN2 reaction, it is a non-polar solvent, low temperature, and stronger nucleophile, stronger concentration. You will, this SN1 and SN2 reaction you will study in your higher class and broadly, but for 2 hours, what you require? Just what is SN1, SN2, some brief idea about the SN1 reaction and SN2 reaction. Okay, students, this much today, and you go through this one. Next class we will discuss the various reactions of alkyl halide. That means, you know, alkyl halide is a key compound, starting compound for various class of aliphatic organic compound. You will see in next class. Thank you.